Today I'm going to be sharing some slides on Sonomatic's subsea phase array offering. I'm Gideon Van Zyl. I'm the operations manager for Sonomatic in the Americas. So our technology that we supply for subsea inspections involves phase array boards that have been provided by AOS. So the reason why we went with these boards is the form factors are very small. We're able to offer advanced inspection solutions, multi-focused phase array, and adaptive TFM technologies. So the initial reason for this system and the development was because we were requested to complete inspection on duplex riser welds. So these were completed on eight welds. We managed to achieve a 98% POD, and the smallest detectable flaw size was 1 millimeter by 5 millimeters in length. Subsequently, after the qualification, we mobilized into the field with a diver deployed inspection solution. We inspected 11 thick wall duplex, dissimilar duplex welds. All of the data that we then provided to the client were used in their fitness for service analysis, and we are now monitoring these welds every 4 years. One of the next things that we did is corrosion mapping inspection. This was actually a repeat inspection that we did for a client from some data that they received from a competitor. The competitor highlighted some potential corrosion issues, which we then went and repeated. What we did, just a high-level overview of the workflow, is we completed inspection modeling where we use SIVA to make sure that our beams are focusing in the correct area in the through-wall thickness of the component. We then collected the data just using conventional phase array. We then did data analysis and processing, and then we highlighted some interesting areas that was also highlighted by a competitor, and we completed an adaptive total focusing method on those areas to improve the resolution. What we then found is that the locations were actually all laminar type indications at fillet welds, and they were likely laminar tears during manufacturing. We also find some early stage pitting that we weren't really able to resolve really well with the normal phase array, but with adaptive TFM we were able to resolve and size them much more accurately. This is an automated bend inspection solution. This was a ROV deployed solution. So here you can see we were able to get 360-degree coverage on the bend and straight sections of the gooseneck and bend. So these were on 8, 12, and 10-inch goosenecks and bend respectively. These are on some risers at the touchdown zone. So we had to qualify an inspection on a blind sample before we went out into the field. So there was 28 flaws that were installed in this sample. All of the flaws were detected, so 100% POD. The smallest detectable flaw measured 0.5 by 5 millimeters in length, so there is an error on the presentation that should be 5, not 0.5. This is actually some images. This was completed at 1,000 meter water depth using TOFD and phase array. The client then used our data to justify life extension of the riser system. So the last two slides, this is probably the most extensive qualification that we've done on our system. That again is a typo. That should be 200 flaws. So we participated in qualification over 12 welds, ourselves, a competitor, and then a different company did immersion UT, and then we did destructive analysis over all the flaws to verify the errors in the system. So 12 welds were inspected, over 200 flaws. After the destructive examination was completed, there was no significant missed flaws. However, the full extent of the study has not been completed yet. You can see there's some images just showing the destructive micrographs over versus the phase array images. And that is it. Any questions? Yes?
Yeah, Gideon, so for that, you just showed, if we back up a couple of slides on those J-level welds, you did some sectorial phase array. Traditionally, right, we use zonal UT for those because of the orientation of the fusion phase. It's hard to show up in the sectorial phase array. Did you guys do FMC with the top? I missed that.
On these ones?
Yeah, on those welds. Or sectorial phase array and top.
So we did TOFD. The TOFD was primarily to make sure that we would still get good coverage on the vertical indications. So interestingly enough, all the vertical indications that we detected with TOFD and with the destructive examinations, not one of them were missed with phase array. And that was just normal sectorial.
You didn't see the phase array?
No, we did.
Oh, you did?
Yes.
Wow.
So there was no indications that we detected with TOFD that was not detected with phase array. But this system is able to zonally focus, but we don't use it in the tandem approach like you would in the pipe wizard systems. We can just define multiple zones of focusing, and it would essentially cover each one of those zones as its own inspection and then merge all the data together in one sectorial image. So in a way, it is a zonal approach.
But even with the oblique interaction,
yes.
They showed up.
Yep. Yep. But yeah, the TOF data was very useful as well. Yep. Yep.
Thank you.
Good deal. Anyone else have anything? Alrighty. That is it. Thank you very much.